Hello, welcome to week 3. We'll be talking about scientific realism. So, as you recall, we're talking about abstract objects, and a big part of the reason to believe in abstract objects was, well, we, our scientific theories, our best scientific theories, we want to say that those are true. And if those scientific theories use numbers as singular terms, right, which, according to Quine, entails that we are committed to the existence of numbers, then I guess we have to buy that because we do want science to be true, right? Um, So I'm going to start with, I've kind of combined two lectures, so this might be a little bit longer than normal. I'm going to try to keep it close to 30, 40 minutes. I'm going to start with the sort of default argument for scientific realism, why we think that, yeah, science is latching onto the world and getting things right. It's fairly straightforward. That's by Putnam. That's not a reading, so I'm just going to explain it. It's fairly intuitive. And then we'll talk about Larry Laudan's pessimistic meta-induction, right, where he looks at the history of science and says, I don't see any sort of inductive empirical reason to think that our current scientific theories are true at all or even approximately true. So I'm not going to waste any more time, and we'll get right into it. So the argument for scientific realism starts with the success of science, and I don't think, I don't think anyone would deny that science has been successful, right? This photo, there's a person on the moon. That is astounding, right? And they made it to the moon, survived on the moon, and came back, right? And that's due to science, right? We can cure diseases that used to be fatal. The human life expectancy has like doubled, um, right? The atom bomb, right? We can release the energy within the atom and destroy entire cities, right? I mean, it's not a pleasant thing, but it's an incredible success in a way, right? It's certainly evidence that we know what we're doing when it comes to science, and none of this would have been possible without science. Uh, So it's certainly reasonable to think that all of this success can't be just accidental, right? That we're just blundering along and our scientific theories are false, but we're somehow managed to send somebody on the moon and bring them back. So science must be getting it right. And the view that our scientific theories are true and that the entities they posit exist is called scientific realism. When I say an entity they posit, right, there's lots of things that science talks about that we can't see with the naked eye or even sometimes see with a microscope. Um, subatomic particles, quarks, and things like that. Um, so scientific realism is in part the claim that quarks exist, right? They really are real things that are there. Um, I think for most people, this is the default view. But we'll see that the story is not quite so simple. So Hilary Putnam, in a reading that I didn't assign, uh, he sort of formalizes this intuitive idea that, yes, science is successful, and so it must be latching onto something into an argument. Um, he really only states it in passing in a sentence, so we kind of reconstruct it as an argument. But he says, realism is the only philosophy that does not make the success of science a miracle. So we call this the no miracles argument, right? The assumption is, well, miracles don't exist, and that would be the only other explanation of how successful science is, right? So people sort of reconstructed this sort of sentence in passing as a sort of argument called an inference to the best explanation, and this is going to come up over and over in the Laudan uh, article as well. So often called IBE, sometimes it's called abduction. It's an inductive form of argument, so it doesn't guarantee a true conclusion, but it's used all the time, and it goes something like this. Premise 1, P is the case. Premise 2, the best explanation of P is Q. Therefore, Q is true. And so you can kind of think of IBE, or one example of where you see IBE used is like detective shows, right, or murder mysteries, right? So here's one example of what P being the case might be. Nate's fingerprints were found on the murder weapon, his footprints were in the house, and his DNA was found at the scene. The best explanation of P, so all that evidence, the best explanation is Q. Nate is the murderer, right? That certainly is one explanation of why my fingerprints would be on the murder weapon, why my footprints would be in the house, why my DNA would be there, because I did the murder. And that's what, if I'm on trial, right, the prosecution, that's going to be their argument, right? They're going to say, look at all this evidence. The best explanation of it is that Nate is the murderer, so you should conclude Nate is the murderer. Now it's inductive, right? So it's possible that I might not be the murderer. Um, and the way you could make that argument is you could say, you know what, Q is actually not the best explanation. I have a better explanation. And that's what my lawyer's job would be, right? The defense lawyer would be to find a better explanation of all the data than the prosecution's explanation, right? And if they can do that, great, right? They can say, oh, actually, Nate's DNA was there because he was there for another reason. So here we have all this other evidence, right, that shows that someone else did the murder, and so on. So this is the structure of IBE. Um, again, it's not deductively valid, it's an inductive argument. And in fact, if you've taken logic, it kind of looks like a fallacy, right? If you're looking at deductive logic, it looks like affirming the consequence. Because it looks something like this. We're saying, if Nate were the murderer, then his DNA would be at the scene and fingerprints would be on the weapon. His DNA is at the scene and his fingerprints are on the weapon. Therefore, Nate is the murderer. So this has in deductive logic, this would have the form, if P then Q, Q therefore P. And that is not a good argument in deductive logic, right? It's like saying, if Spot is human, he's an animal. Spot is an animal, therefore he's human. Well, that's obviously a bad argument, right? Because Spot can be an animal, but be a dog, not be human. So IBE is used all the time as inductive reasoning, right? We say, well, we have, all this data, all this evidence. Here's one possible explanation. It seems like a pretty good explanation. Maybe it's the best explanation, so maybe it's true, right? But it's a big maybe, right? There's certainly lots of other. All you need to do is find a better explanation, and the conclusion turns out to be false. Okay, people have interpreted Putnam's no miracles argument as an inference to the best explanation. So he's sort of saying there's two possible explanations of the success of science, right? How we're able to put people on the moon and all this stuff. One explanation would be our scientific theories are true, right? We're latching onto the real world. We're beginning to understand the world well enough that we're able to predict things. We're able to manipulate and sort of harness the laws of nature, or at least, act in accordance with them so that we can shoot a rocket to the moon and so on. Another explanation would be we're just getting really lucky over and over, right? And science is not right. It's not getting it right. And yet, kind of by accident, we put people on the moon, and by accident, we discovered penicillin. And right, all of these technological marvels, they're just accidents. They have nothing to do. We just got lucky over and over again. That, he says, would be a total miracle, right? And he's saying, look, the miracle explanation is not the best explanation, right? It's a pretty rotten explanation. Therefore, the best explanation is the scientific theories are true, and we should believe the best explanation by IBE. So if that argument seems convincing, or at least appealing, and he's not, again, it's inductive. He's not claiming that it couldn't turn out to be false, but he thinks it's a reasonable claim to make. It's a reasonable argument. And if you're convinced by it, then you are a scientific realist, right? You think that scientific theories that achieve a certain level of success in prediction and experimental testing are probably at least approximately true. If you don't believe that claim, you are an anti-realist. So anti-realists don't have to deny that the science is successful, right? What they'll tend to say is that theories can be successful without necessarily being true. And we'll see that Larry Laudan is an anti-realist of this sort. He doesn't deny the success of science, but he says that doesn't entail its truth, right? That's not the best explanation. Okay, so hopefully that was all intuitive and makes sense. This is probably what most of you believed anyways, right? Yeah, science is super impressive. Look what I can do with my phone, right? And that proves that our scientific theories are true. So now here comes Larry Laudan, and he's got some other ideas. So Putnam's no miracles argument, again, it's sort of an empirical argument for scientific realism, right? It's using evidence in the form of all these scientific successes to make an inductive argument for realism in the form of an IBE. Now, this is actually a fairly bold strategy, right? And all science is bold in this way. It means it can be falsified. And this is Laudan's what Laudan intends to do is to falsify what he calls convergent epistemological realism, or CEV. So it's sort of a complicated term, right? You don't necessarily need all the distinctions or know like, well, what's special about convergent epistemological realism? I'll explain it, right? But it's just he's going to refute scientific realism, right? So CEV is the claim that the success of science is evidence that our successive theories. So I used successive and success in the same sentence and probably shouldn't have, right? But success of science is evidence that each new theory is getting closer to the truth. So if you believe CEV, right, this kind of scientific realism, then you're committed to several claims. Claim R1, scientific theories, at least in the mature sciences, right? Some sciences are just beginning and we allow that it may take a while before they really latch on to reality, right? But the mature sciences like, physics and chemistry, again, CEV is committed to the claim that those sciences are, at least those theories are typically approximately true. Right? They might be improved, right? But they're close to true. And that more recent theories are closer to the truth than the older theories, right? So theories are getting better and getting more and more true or closer to the truth. Claim R2 is that the observational and theoretical terms within the theories of a mature science genuinely refer. So refer just means picks out something that exists, right? So when I say the word Santa Claus does not refer, right? There's nothing that it picks out, but Nate does refer, right? It picks out an existing person. So R2 is the claim that when we talk about electrons or quarks, right, or electromagnetic force, there are things in the world that correspond to those terms, right? That science is getting it right, that when we talk about electrons, electrons actually exist. Claim 3 of convergent epistemological realism, the successive theories, again, the next theory and then the next theory, in any mature science will be such that they preserve the theoretical relations, apparent reference of the theories before. So what this means is the claim is we're converging on the truth, right? So as we do science, we don't just have a theory and realize it's false, trash it, come up with a whole new one from scratch, realize it's false, trash it, and so on. Instead, each new theory sort of builds on and refines the previous theory, right? And the classic example is Newton's mechanics, right? Newton's physics, which was very successful for a long, long time. And then Einstein and relativity came around and basically said Newton's physics basically true, for medium-sized objects relatively close to the Earth, not traveling too close to the speed of light, right? But once you get really massive objects or objects that are moving really close to the speed of light, Newton's mechanics starts to get really false answers, right? So Newtonian mechanics ends up being a limiting case of the better, newer theory, which includes not only stuff that's relatively small and relatively slow, but also stuff that's really big and really fast, right? So Newton's mechanics is true for small, slow objects. And then R4, acceptable new theories do and should explain why their predecessors were successful insofar as they were successful. So now that we have, right, Einstein's relativistic mechanics, we can make sense of what was good about Newton's mechanics. And finally, R5 is the claim that the previous theses, R1 through R4, entail that mature scientific theories should be successful. And indeed, these theses constitute the best, if not the only, explanation for the success of sciences. Okay, so the inference for the best explanation, right? And again, this is basically a version of like Putnam's argument, but a little more precise. Premise 1, our mature scientific theories are successful. Premise 2, the best explanation of the success of our mature scientific theories is that they are true and their central terms refer. Conclusion, therefore, our mature scientific theories are true and their central terms refer. Okay, so that's the IBE. And remember, I said that IBE looks a lot like affirming the consequent, right? it's sort of like if P then Q, Q therefore P, which is not deductively valid, but it's a reasonable sort of inductive argument. But Laudan's going to sort of make use of that conditional in his argument. We'll make them up later, right? But again, it's sort of like saying if Nate is the murderer, then his DNA will be at the scene. His DNA is at the scene, therefore I'm the murderer. Well, that's not deductively valid, but it might be the best. So R1 through R4 are empirical claims, right, about how successful our theories are and so on. And then R5 was a sort of meta principle that links all this empirical evidence about how successful our theories are with a conclusion about whether they're true, right? A conclusion about scientific realism. Okay, so given all these claims, right, now we can construct two distinct arguments, one based on truth and one based on reference. And they both have the same, they both get at the same point. So let's look at the first version. Premise one, if scientific theories are approximately true, they will typically be empirically successful. Premise two, if the central terms in scientific theories genuinely refer, those theories will generally be empirically successful. Three, conclusion, the third premise, scientific theories are empirically successful. Therefore, four, probably the theories are approximately true and their terms genuinely refer. Again, this is an inductive argument. Like this looks like two affirming the consequence, right? But the idea is, yeah, that's the structure. In the inductive version, it's fine, right? We have the success, and the success would seem to explain, the truth and the fact that the theories refer would seem to explain the success. So why do we say convergent, right? So realism, hopefully that makes sense. That's the claim that, right, science is true, or it's the words refer. Epistemological just means it's about knowledge, right? And then convergent is the idea that the theories are getting gradually better, and they're improving on our old theories. So the old theories weren't just totally wrong, right? So that gives us this sort of argument. Number one, if the earlier theories in a mature science are approximately true, and if the central terms of those theories generally refer, then later, more successful theories in the same science will preserve the earlier theories as limiting cases, right? And two, this is what we seem to do, right? We try to preserve earlier theories as limiting cases, as in, classical mechanics and relativistic mechanics, and we generally succeed. Therefore, again, it's this IBE, but the way he sets it up, like affirming the consequent. Earlier theories in a mature science are approximately true and genuinely referential. Right? Okay. So, of these two IBEs, he thinks 4 of the 5 premises are actually false. And even if they were true, the conclusion wouldn't follow. So he's really going to sort of tear both of these sorts of arguments to shreds. So, again, we basically had 3 arguments. We had an argument from, well, he combined 2 into 1. So it's reference entails success and truth entails success. And then the second argument was about convergence, right? So let's talk about truth and reference. Start with reference. What we mean when we say a term refers is that the thing it represents actually exists, right? So the reference of the word cats are cats. And the word cats does refer because cats exist, right? So the question is, in terms of science, right, is there a referent of the word electron? Right? We tend to say, yeah, of course. But remember, in science, there were all sorts of terms in our old scientific theories that now we think don't exist and don't refer. Phlogiston was one of them, right? People thought that was some sort of substance that made things combust. And they didn't realize it was basically oxygen, right, that made things burn. They thought it was the phlogiston. Everything had a little phlogiston in it. Okay, so the question is, right, there's 2 separate questions that you could critique here. One, do our scientific terms really actually refer? And number 2, even if they do, right, does that entail the success of science? So again, I mean, he says he's being very precise, right, in his inferences here. You don't have to follow every detail. He seems to be very repetitive for that reason, right? He's making slightly different points at each stage, uh, but you can get by with the general idea of what he's getting at, right? So again, so now he's like S1, S2, S3. Yeah, I'm sure you're getting lost with all the R1s and R2s and S3s and the various. But again, our three main points is like, uh, does the success of science entail that, right? Scientific theories refer, which is what we're talking about now. Right? Scientific theories are true, right? And that they're converging. Okay, so here we get a premise. The theories in the advanced or mature sciences are successful. S2, a theory whose central terms generally refer will be a successful theory. S3, if a theory is successful, we can reasonably infer that its central terms generally refer. S4, all the central terms and theories in the mature sciences do refer. So Laudan thinks of all these, maybe only really number one is true. And he's gonna doubt all these other things that a scientific realist would probably believe. If you if the terms refer, it's successful, or if it's successful, the terms will refer, either one, right? Um, or that all the terms in the mature sciences refer to that. So he does accept that the theories are successful, right? He just doesn't accept that being successful tells us anything about the truth of the theory. Right? So what does it mean for a theory to be successful, right? So realists, he thinks, usually mean something like this: it makes correct predictions about the world, right? Or and other realists might say, well, what makes a theory successful is that it allows us to manipulate the world in some way, right? It allows us to send people to the moon and so on. Um, and if they want to be convergent realists, they do want to say that the old theories are also successful in a way too, right? So their theory, their definition of success needs to capture that as well. Um, Now, old theories did make correct predictions to a point. That's why they were accepted for a while when they were. Um, and then the idea is for the convergent realists that new theories are going to make all the same predictions plus more, better and newer, right? And the converging on the truth. So on this account of success, S1 is true. Theories do make a lot of good predictions. Our best theories make a ton of good predictions, and even the old theories made a bunch of good predictions, right? But what about S2? If a theory's central terms refer, it will be successful. Not really. So, for an example, chemical atomic theory in the 1700s was not successful at all, right? So they were they had latched on to some truth. They had some referring terms. They believed that hydrogen, right, hydrogen appeared as a term in their theories, nitrogen and so on. But they were dead wrong about the relations among those things, right? So they thought that um, heavy elements like lead were made of hydrogen atoms. Not true, right? They thought that um, water, they figured out that water was hydrogen and oxygen, but they thought it was HO, not H2O, right? Well, hydrogen refers, right? Oxygen refers. Those are atoms. Those are things in the world. Um, but still, your theory is not successful, right? It's dead wrong. And it's going to give you very wrong predictions if predictions is your measure of success, right? So, long story short, you can latch onto all the right objects, but if you don't have them related in the same way, in the right way, you're not going to have a successful theory. So S2, we have evidence from the past that S2 is not the case. Just having central terms that refer does not infer success, right? Which means that success is not um, best explained by the central terms referring, right? Well, what about S3? The other way around. Um, Maybe if a theory is successful, then we can figure that its central terms will refer. But a lot of our successful theories employed non-referring terms. So phlogiston was one of them. Pardon me. Phlogiston theory did make some good predictions, right? That's why they stuck with it for so long. And there's a whole history of scientific theories that were getting it wrong. They thought electricity was a fluid for a while. The theory of heat, caloric, was also a kind of a fluid, right? Which was like that made things hot, right? And caloric would flow from hot things into cold things. You have the ether, right? They thought the whole universe was, they thought space was not a vacuum, but it was filled with something they called, um, and so on, right? So there, yeah, there's a whole litany of terms that were used in our scientific theories that we don't use anymore. We don't think they refer to anything that exists. Um, but those theories did make successful predictions, right? So either way, this connection between referring and success is broken, right? Just because your theories refer doesn't mean they'll be successful, and just because they're successful doesn't mean that they'll refer. Okay, so he's broken down the connection between reference and success, saying, look, that version of the IBE for scientific realism is not going to work. Um, just because their scientific theories are successful, it doesn't really tell us anything about whether their terms refer. Now let's look at truth. So this argument for realism can be, we can break it down into a couple. If a theory is true, or at least approximately true, then it will be explanatorily successful, right? Or vice versa, if a theory is explanatorily successful, then it's probably approximately true. Again, that IBE requires some sort of connection between success and truth, right? For, again, success of science to be best explained by its truth so that we could then conclude that it's true. Now, even the realists don't stop short of actual truth, right? They know that, yeah, probably our current theories will be improved. You know, before Einstein, right, we thought Newtonian mechanics, people really thought Newton had just solved basic laws of the universe, right? It turns out he was wrong. So if we're at all humble, we might say, okay, Einstein made a big advance, but there's probably going to be, right, some improvements down the road. So they're not going to say science is true, full stop. They'll say our current theories are approximately true. They're close to the truth. They're getting closer. Now, if you could say they were actually true, that would make T1 and T2 more plausible, right? If a theory is true, it will be successful. Yeah, that makes sense, right? If a theory is successful, it will be true. Maybe, right? Um, T1, though, definitely that would make sense, right? Yeah, if it's true, then that would make sense. But the problem is they can't say truth, right? Because they know it might be improved. The theories might have to be improved. So all they can say is approximate truth. And when you just say approximate truth, it's not clear at all that T1 is true, right? Why would an approximately true theory be successful? First of all, what does approximately true mean? It mean like mostly true. Uh, a mostly true theory has some false, right, axioms in it, and all you really need is one false axiom to make a whole ton of false predictions, right? Even possibly mostly false predictions from that theory. So T1 is false. If all you've got is approximate truth, then you don't. There's no reason to think that you'll have a lot of successful predictions at all, right? Because one false axiom in your theory can just wreck the whole thing. Okay, so what about T2? This is kind of the whole question, right? What about if a theory is successful, then we could say it's true, right? Again, uh, that's the whole argument for realism. But we have to say, we'll go back to the point about reference, like no theory is going to be even approximately true if its central terms don't refer. And we have a long history of successful theories whose central terms don't refer, right? We listed some of them. Ptolemaic astronomy, right? So they had all these sorts of like epicycles in the orbits that don't exist. Um, the humoral theory of medicine, right? The four humors that explained, right? Oh, you've got too much, right? You got too much blood. We need to, right? You need a bloodletting, right? Or you got too much bile or whatever. There were the four basic humors in the body that they thought were responsible for sickness. Um, yeah, there's no such thing, right, as a humor. The caloric theory of heat, as I described, that is not the substance that exists that makes things hot. What makes things hot is molecular motion. The phlogiston theory of chemistry, again, it's not phlogiston that makes things burn, it's oxygen, basically, right? And so on. So, um, you know, these aren't just historical oddities, right, that don't have a lot to do with modern science, right? Um, for example, right, so all the science that talked about the ether, right, where we talked about the ether, there's no science, is the idea that space isn't a vacuum, but it's all filled with this ether, and that's what everything, all the planets float in or whatever. Um, a lot of the science and a lot of the equations that were developed for that were kept when we moved on to electromagnetic theory, right? So there is a lot of continuity between these old theories that with terms that don't refer at all and that are false in many ways with our current theories, right? And they were very predictably successful, but just straight up false. So the idea is success is not an indicator of truth, right? There are lots of successful theories that were not true because their central terms didn't. So T2 is false. Okay, getting towards the end. Not too bad. We're at 31 minutes. Okay, so another claim of convergent realism, right? This was the third argument, or we had one argument that had two parts, right? The truth and the reference of scientific theories and whether those are connected with success in any way. And he said, no, they're not. And the other thing is that, oh, science is converging on the truth, and we have these old theories that end up being special cases of the newer theories and so on, right? So Newtonian mechanics turns out, is strictly speaking, false, but it's true as sort of a limiting case for relatively small objects at relatively small speed. But Laudan points out that that example is doing a ton of work, because most of the time that's not how it works, right? Most of the time, the old theories actually do get totally tossed in the trash heap, and we have newer theories. So here's his quote, right? And I'm not deep into all these, like, I don't know Franklin's or Nolit's electrical theory, like all this history of science, right? But he's just giving us examples of like old theories that just got tossed in the trash, right? That weren't converging on the truth. It says Copernican astronomy did not retain all the key mechanisms of Ptolemaic astronomy, for example, motion along an equant, whatever that means. Newton's physics did not retain all or even most of the theoretical laws of Cartesian mechanics, astronomy, and optics, right? So even though, yeah, maybe relativity is a good example of how the previous one is a limiting case. If you go back further in history, before Newton, there was parts physics, and that one got thrown in the trash. Franklin's electrical theory did not contain its predecessors as a limiting case. Relativistic physics, even the best example, didn't hang on to the ether, right? They tossed the ether away. Statistical mechanics doesn't incorporate all the mechanisms of thermodynamics. Modern genetics doesn't use all of Darwin's stuff. And as a limiting case, wave theory of light does not approximate corpuscular optics. Modern embryology incorporates a few of the mechanisms in classical embryological theory. I don't know a lot about embryology, right? But you do, and you think Laudan's wrong, let us know. But at least Laudan says the examples of convergence, right, where you keep the old theory as a limiting case of the new broader theory, are actually kind of fewer examples than way more examples of where they just threw away the old theory. Even this convergence doesn't actually exist, he thinks. It's, again, a reason to think that science is successful. I'm sorry, that science's success entails its truth, that it's converging on the truth. He agrees that it's successful. He'll accept that premise, but none of the other stuff. Finally, after doubting basically every premise in the IBEs except that science is successful, he's also not even sure that an IBE is the best approach here, right? Of course, it's not a valid approach. It's technically a form of affirming the consequent, but some people think that that's how science proceeds, by IBE. You come up with a hypothesis, which is like the best explanation of the data, right? And so you say, well, the hypothesis is true. This explains the data. Laudan kind of denies that. He doesn't think IBE is the best way to describe how science happens, actually. You don't get the details of that. He says, look, you can always kind of come up with some conditional whose consequent is true, sort of ad hoc, but that doesn't really give you a good reason to believe the antecedent. So you need, again, ad hocness is something that sort of the scientists worry about, right? So if you have the data, and the classic version of this is astronomy, because everyone sort of has the same data, and there's not a lot of new predictions to make. You know where all the bodies are, and you know where they go, and so you're trying to just explain. You're trying to have a theory of these bodies based on the data you can see from on Earth of like the motions of these dots. And what happened in Ptolemaic astronomy, where the Earth was the center, right, was that to explain the motions of the planets, they had to get more and more elaborate. Say, oh, what's happening is the the planets are not only orbiting the Earth, but they're also doing little orbits within their orbits, right? And they even had to add little orbits within the orbits within the orbits and stuff like that. Those are called epicycles, right? So you can make your theory give the right predictions if you add enough epicycles, sort of ad hoc, right? Um, but the better test, or what we tend to think a good theory is one that makes a new, bold prediction um, with new data that nobody has yet, right? Um, when Einstein did this, so his theory predicts that, hey, if you took a very precise clock, flew it around the world a bunch of times, it would actually, when you landed, it would be slower than the earthly clock. Time, dilates the faster you go. You actually do it, and it's actually true. That's astounding, right? That's a really bold prediction. Turned out to be true. Um, so he thinks this IBE sort of approach, argument for scientific realism, is sort of ad hoc, right? And it would be more impressive if you made some sort of prediction rather than sort of gerrymandering your theory to match the data. All right, well, 36 minutes. That's better than that's as good as I had hoped for. I hope, yeah, if there's any questions or anything, we'll talk about it on Monday. And yeah, have a good one.